Hello everyone and welcome to DevOps Summit 2021. I'm Misnad and let's talk about telemetry and its role in monitoring today. So before we start, a little bit about me. I'm Misnad Haque and I live in Colombo, Sri Lanka, a small island just south of India. Um, I started my career in software development and have moved on since then into IT operations, working as a full-time SRE, basically facilitating SRE for the organization. I've got about 18 to 19 years of experience right now, and I work at an organization, a global company that serves Fortune 500 companies globally as well. So I've seen how things, have evolved. The applications have evolved from the legacy desktop swing AWT applications all the way into client server and then into distributed microservices systems right now. So it has been quite interesting to see how observability has changed, our monitoring has changed from the good old days into how complex it is right now. So let's take a typical client server system just to make it easy. Microservices are complex and all. So let's just look at the typical client server system. So what happens here? Initially, what would happen is you would just have an application right in the middle. It's a black box of its own. You'd typically have a web tier, some middleware. It could be WebLogic server and so on, Apache, etc. You could even have a database on the other side. So what would happen with the database would be it would have the data model and it would store all the definition that's required for this particular application, right? So let's assume it's a simple three-tier system. Let's complicate it a little bit. Behind this application, it would also talk to several other systems. So maybe you have your web portal on this side. It talks to maybe an inventory system through message queues, and then you would have maybe that one talking to another system where it gets its pricing detail through a REST call. And you'd have database links and so on for maybe promotional information and so on. So this is literally a slightly, well-connected system. It isn't distributed by any means. They are actually monoliths. However, this used to be the typical approach. The user would log into some site through HTTP, access the application, and behind it, it would interact with the other applications as well, providing the response back. So in terms of the user's perspective, all they see is a big black box. They wouldn't see any of the other systems happening in there, right, or interacting. So what would we look at when we try to do a monitoring or try to implement monitoring? One of the first things we would look at is real user monitoring, or just even synthetic monitoring in the good old days. So we would look at things like page load time from the user's perspective. Were there any 404 errors, 500 errors, HTTP, etc. We would look at the clickstream. Now, this is interesting because it would have an impact on how we do analytics based on a user's journey. And then we'll probably look at the access rate, hit rate, and so on. When we go into the application itself, our main application here, we'd have application monitors like server, infrastructure. You do business transaction monitoring end-to-end, which, trust me, is a real pain to implement. And then we had obviously database and then into application monitors. So looking at the MQs, the queue depth, the REST calls, maybe connectivity checks, and so on. So this used to be a very simple approach, and you'd have third-party systems that you could, or products that you just deploy and monitor the whole thing. And it used to just work. You just set traps, you set alerts based on this, and you just see all your data. But now it's no longer this simple. When you look at microservices and the distributed architecture, things have got way more complex. As you can see, that monolith that may have been written just in Java is now running in microservices with several different languages. And they all speak over REST and API calls and so on, even RPC. However, the big problem here now is that you would have multiple languages and they can be deployed in Docker containers, managed by Kubernetes, and so on. So your standard off-the-shelf monitoring system of the good old days and the way that it was implemented before can no longer function here, because if you look at it, the microservices for a single transaction, a single user click, or maybe a single journey, it could have 100 different microservice calls, different service calls that go on. So they are distributed now, and now you'd have to monitor each and every call, right? So how many different monitoring tools do you think you'd have to build in this case? Or you can have several, end up having several monitoring tools now, right? And just picture how troublesome it is going to be when it comes to E2E or end-to-end monitoring and tracing. Central logging, that used to be the beauty of everything. You just dump everything into a central log and push it into your backend, monitoring backend, and everything's fine. Not anymore. And even worse, if you have a system where they are transitioning away from monoliths to microservices, you now have a hybrid. So what happens at the end of microservices is you have a monolith at the backend. It used to be very simple, similar to the monoliths talking to mainframe systems at the backend. It was impossible to have E2E monitoring there, right? Or visibility. So how do we go about all this? So one of the first things you do is basically look at, how do we monitor things? Um, it isn't really a very simple, straightforward approach where you just have a list of all possible monitors that you'd want to implement and then just, start creating all these, collectors and visualizations and so on. No, that's not the way to do it. You've got to study it from the grassroots. What do you want to really monitor? You need to monitor only things that are necessary. And for that, there's an exact science for this. It's like you have black box and white box monitoring. So black box would be something that's outside the system. What would the users see? What would other systems see or on top of this particular system? So it can be load times, response times, maybe whether SSH calls have been successful, etc. Right? You just treat the application itself or the microservices as a black box. Then comes the other part where you look at it inside out. Within the services or within the application, you'd have metrics, logs, traces, right, and even events, right? So we call it MELT or MELT. So when it comes to this, you'd want to look at, for example, a particular procedure in the service being executed, when it started, when it passed on the message, when a variable was set, when it called the next service, and so on. So you'd want to have traces in that case. And then metrics is something like where you want to see the number of calls, the number of messages that were passed, and so on. So those are just finite numbers that can keep on incrementing, right? And then of course the logs for any events that occurred, so that you can do your troubleshooting and root cause analysis. So it just doesn't happen out of the box. You'd also need to instrument your code, and by that you can just do a one-off instrumentation, apply the traces and so on, create your spans and so on, and then you could just start observing after that. However, can you simply apply this level of monitoring for a combination though of monolithic and microservices? Now that's an interesting thought. You can do this for microservices. However, for monoliths, it will take a lot of custom coding there. You'd have to look at the elements of monitoring here. You'd want to look at the different four golden signals, which is Google's main standard that they call. So latency, traffic errors, and saturation. You'd want to look at monitoring things from those different dimensions. You basically build your SLIs or service level indicators from those areas. And when it comes to a particular white box monitoring, which is looking at the microservices itself, you'd want to go with MELT, the metrics, events, logs, and tracing, right? And then of course you have different ways of having this. So for monitoring, you'd have the data collection. How do you pull the data? How do you store the data? How do you visualize it? What do you do after that, right? How do you analyze it and do your root cause analysis and so on? Now that becomes something afterwards, right? It becomes a problem later to handle, right? But the foundation of it is you need to see what's going on underneath. Now, when it comes to microservices, what would you think of simply just looking at log files? The legacy approach was you just have some event happening and just thrash it into a log file. And you just alert based on log files. I mean, if you look at systems like Elasticsearch, they were built to look at log files. And you'd maybe create your visualizations based on events that are logged on the log file. What about tracing though? And now just imagine how complex these microservices systems have become. Now, when you try to trace something, it's a real spaghetti. That's where things get really complicated. In the past, maybe you could have a single message ID and a transaction ID and just float it across different systems. It was a bit easier to handle. However, now you would have thousands of these calls. So just trying to dissect them is chaotic in the very least. So how do you do this? There's a concept called distributed tracing, and we shall see about it. Before that, we'll also talk about what it means to really do telemetry, okay, and what it means to actually monitor a system. So one of the first things is with telemetry, we are looking at exposing the analytics data or maybe the performance data from one system and moving it to a remote place, right? Or a backend is what we call it. And observability is basically the measure of how well we observe these internal states, right? Or how well we do white box monitoring, okay? Because if you can't observe, you can monitor all you want, but then you'll just simply do something called seeing. You can only see, but you can't really observe, right? You can't take any action based on it. You just see. You just see the result of maybe a major catastrophe going on within your application. You can't really observe what's going on under the hood. Now, for that, you need observability. So it's way beyond just a fancy word for monitoring. So observability looks at three different processes. One is how you collect the data out of the system. How do you extract the data? How do you extract the telemetry from the system, right? The telemetry data. Second is how you monitor this. And this would be about, your visualizations. How do you create your dashboards? What type of gauges you'd want to see? What type of trends you'd want to see? Can you just see it visually, right? Or maybe, even log it somewhere else in a remote system. And finally, when you look at analyzing the data, can you make sense of what you've visualized, right? So you actually would create something actionable. So it's only when you have all three of these that you have proper observability. Now, why do we need telemetry? And telemetry is fancy and all, right? But there could be different business goals even, right? So if you look at what I've shown here, there's a small snippet of the Windows developer blog for Windows Store application. You'd probably want telemetry to, identify how well your application is growing in fame. So in that case, you'd want to probably look at, the number of hits, and you'd want to see how people are using your application, which parts are more used, and so on, right? Maybe even for fun, right? See how much your employees or how much your customers are enjoying the systems, right? How are they using it? Are they liking your application, and so on? So you could trace all of this. This is the reason why you'd want to do telemetry. But more than that, if you look at an actual SRE, the SRE would focus on telemetry to understand what's going on under the hood of the application, and in case there's a problem, how do I diagnose it? How do I fix it, right? So that's the purpose of telemetry. You want to see what's going on at the granular level, okay? So we looked at tracing on and off in the previous slides. However, when it comes to distributed tracing, as in like the concept of distributed tracing, it's actually quite a beautiful concept, to be honest. When you look at it, the best example is, if you open a web browser, and regardless of what it is, Edge or Firefox, Chrome, whatever it is, your favorite browser, go into the developer tools and just, go into the network tab, browse some web page, just open up a web page and take a look at the waterfall that comes up. So you'd see a series of all your resources that get loaded for that web page. The JavaScript, the CSS files, the whatever it is, right? The images and whatever other resources. And the amount of time it takes for each of them to execute, right? And you'd see them in a nice, beautiful waterfall. It's an end-to-end trace of that particular web page. The different tiny little calls or dependencies are now traced out beautifully. And if there are errors, you could see them as well, right? So that's the simplest view of tracing, okay? Now, let's look at it in the context of microservices. So you'd have something called a span. That's the very smallest object or smallest kind of entity in the entire trace, right? So this can be a single process call. It can be maybe a HTTP request. It can be, a database query and so on, right? So it's the smallest little uh, call, right? And from that span, you'd also have multiple spans can interrelate with each other to form a trace. So you'd have a sequence of spans, or maybe parent and child spans and so on, and they'd all work in sequence, and then all that can be a trace to execute a single function. All right. Now within that you have something called transactions. So that can be browser-based transactions, or backends, or database transactions, and so on. Let's just ignore that for now. I'm not talking about the end-to-end transaction from a business perspective. That's like looking at adding something to your shopping cart and all the way into checking it out and so on. Not that. I'm talking about a trace for within the microservices calls itself. Okay, so it's a series of different spans there. Now, with each span, it would have its own unique ID. Okay? So that's how you identify a span. However, one thing to note is the span ID is unique within a particular trace. Okay. Now you have trace IDs, and trace IDs are unique across different traces, right? However, a span is unique to a single trace only. The same span ID can be used in a different trace ID, and it does not have anything related to this particular span ID at all. Okay, it's relevant to the context of this particular trace. So apart from that, with that span ID and the trace ID combination is where you could have almost like a composite key. That's the unique identifier, really. Okay. Um, so apart from this, spans can also have children. Okay, so you have a main span executing, and it can call sub processes, right, or be different calls in there as well, which could call other sub calls and so on. And all this is required for a single span to execute. Okay, so basically parent and child. The parent span would obviously not have the root span, rather would obviously not have another parent, and any other span that came underneath that would actually have the parent tagged as span A, right, as an example. And maybe span B has a child called span C. Obviously, the child that is called span C, parent would be span B, okay, and so on. So you could create a whole load of these spans, okay, and that would form a bigger span. Okay, so you could look at each, or you could trace each and every one of these spans based on the relevant span IDs. Okay, now the combination of all these spans together is actually called a trace, right? So you'd have something called a trace context, which acts as the glue between the different spans. Okay, so that's the one that just gives some information about the trace. Okay, now beyond this, you also have something called span context, and span context is useful because it helps link different spans across the network boundaries. Okay, now this is a set of key value pairs. You could have baggage items, and by baggage items doesn't mean that it's unnecessary. It's anything that gets carried along for the ride. Okay, take an example. You have a particular product. Let's look at business transactions now. You have a particular product, and that product is being used within this particular span. Okay, or it can be used across different spans. Okay, so you have this particular product, and you'd want to have this product ID. Take the product ID for a ride, because in your end-to-end business transaction monitoring, you want to see how these spans affected that end-to-end transaction. Okay, so you could add that as a baggage item here, right? So you could say product ID equal whatever, right? Or not equals colon whatever. Okay, and that could be the baggage item. Apart from that, you could also have raw logs in there, so that can also be added as baggage items. Apart from this, you have tags and logs. So tags are basically annotations to make sense of what a span is, and then you have logs, which can be just a simple log message that you want to print, or you want to pass on to your centralized logging as a key value pair. So we've spoken about distributed tracing now. what's open telemetry? There's actually a framework for this, and this is almost a standard. Where we in the past, when you have so many distributed tracing implementations, you can have each vendor. Maybe I could develop in my own way, someone else could develop it in their own way, and you have to build it from ground up, right? You have to build your framework, and then you have different standards all over the place. You could have several open source standards, but which one do you pick? It's very unlikely that you'd have one common standard across all. It's like, when you look at things open source, it's always the case where the next standard is just another standard in there, right? It's not a standard to outdo all the other previous standards. It's just another standard. However, you can actually go for a globally accepted standard, and that's where you eliminate the vendor lock-in, right? So that, just imagine the pain. You build one particular application, and you build a custom, kind of custom framework for telemetry, and you'd have to build another one for the next one as well, right? So it's really painful. And assuming from the role of a client, the point of view of a client, they would actually feel that, oh, without this particular vendor, I can't do anything, right? I need to go back to this particular vendor to view my telemetry data. So I can't maybe have something in a different language and so on, right? So that's where open telemetry comes in. It aims to simply build on a single platform, provide you an engine of sorts where you can extract your telemetry data from your applications. You can do auto instrumentation and so on, and you can do manual instrumentation as well. However, auto instrumentation is provided with open telemetry, and it's obviously the merger of open sensors and open tracing. Where open tracing was basically an API that used to be used for tracing, purely an API. You'd have to take care of all the other stuff in terms of exports and collecting data and all that stuff. That had to be done separately. You'd have to build it on your own. And then you had open sensors, which was mostly focused on metrics, right? And it was a Google project, and so now it has combined together with CNCF being a firm staunch supporter of this, and they've looked at a proper distributed tracing approach, right? So if you look at how it functions under the hood, open telemetry, it provides you a few different approaches of extracting the data. One is you use your open telemetry library within the application, and you simply to do your instrumentation and so on, and then you'd to build your spans, and then you'd have the open telemetry collector, and it can run as an agent, as a sidecar, or anything with the application. And that's the preferred approach, really, right? Where the collector would simply extract the data from whatever is from your application, and this can be both metrics and traces, and push it out to a different backend, right? And your backends can be one dedicated to purely metrics, or another one that is running both open sensors and open tracing, which is open telemetry, right? But one thing to understand though is open telemetry isn't really a backend of sorts. It is just a mechanism to extract your data, your telemetry data from your application into a third-party backend. Okay, so if you're using your Prometheus or Elasticsearch and whatever, you can still continue using it. Those would be the backends. The second approach is where you would have an open telemetry collector agent running and feeding the data into a different service. Now, these could be a series of collector agents running in its own Docker, right? In its own Docker container. So maybe you'd have a pool of these running as a service. So if things get a bit more complex, or if you have an existing deployment that's already there, you don't necessarily need to re-instrument. You don't necessarily need to redo everything with open telemetry collectors. You simply have to just you can move it into the collector service on its own, and that could push the data to the relevant backend. Okay, so understand that you don't necessarily have to choose. If you use open sensors or open tracing, you can continue using it. If you're brand new to it, if you just want to start out with your telemetry, you can simply use open telemetry as is. Use what is available right now. Okay. Big question. What about logs? Right? So we spoke a lot about traces, but what about logs? So OpenTelemetry is standardizing on logs as well, and it has a good definition. It's still in the experimental phase. It is planned for general availability, hopefully somewhere in 2022 after metrics is brought in. However, when it comes to logs, there's a particular standard it looks for. You're looking at timestamp, you're looking at the trace IDs and spans and so on. Now, this is very important because in the past, you could just log anything and everything that you'd want. You can still do that. However, it's much more recommended that since you have the tracing capability now, you use tracing along with logs. You merge the two. You make your logs a little bit more useful rather than just being just a simple dump of things where someone has to crawl through trillions of them, trillions of lines of logs to just simply, get to somewhere. So if you can simply have the log as the main raw, data store for all the events that have gone on, so that can aid troubleshooting and diagnostics. And you have traces just to pick out saying, okay, look, at this particular span is where things went on. So then from that span, I can just go into a particular log and see, look, these are the details of the errors, right? This is exactly what went on, right? For maybe this particular business transaction, this is what happened, okay? So, and it's very clear. And from those logs, I can create alerts as well. I can even, generate if you remember the good old log4j, you'd have the different log levels, right? The severity levels, the warn, info, error, etc. Same thing here as well. So you can have a different log level and look at the ones that are critical. So if it was simply informational, you probably can avoid it, right? And this is a good structure in terms of how the logs will be, built for the microservices now in this case, right? How you can just merge the telemetry data from traces into logs as well. So now it's starting to be a bit more holistic, and it's actually enriching the entire log. You'll also have this problem now. You've already deployed your existing monitoring tool. However, don't fret, they do work. So if you use, for example, Elasticsearch, they do have Elastic Observability, and they work with OpenTelemetry seamlessly. They have their own telemetry protocols and so on. They have the Elastic protocol. OpenTelemetry can speak to that as well. It can go into the OpenTelemetry protocol and straight into Elastic Observability. So you get plugins for each of these, and it works with Elastic APM server as well. Dynatrace is brilliant at this as well. So you can visualize your service maps. It has its OpenTelemetry collectors and so on. So it will work, right? You just need a little bit of customization, go into the APM kind of things rather than the old monitoring kind of approach where you look at applications as almost black boxes without without looking under the hood. Right. So we've spoken quite a bit. However, what do we do now? My advice is to get a bit more intrusive and a bit more detailed in terms of what you monitor. Try to build more context into your telemetry data. So enrich your white box monitoring. But at the same time, do not forget about black box monitoring because it's absolutely important to understand how users and other external systems see your application performing. Okay. Um, Beyond this, there are several different tools available, different monitoring systems. Try to give your SREs a break, your operations engineers a break. Just avoid having them to go through multiple different systems and dashboards just to diagnose something. And at the same time, be careful about creating dashboards. Separate your diagnostics from SLOs and compliance dashboards because it tends to be too noisy. And finally, follow OpenTelemetry's project progress. Traces are currently generally available, metrics expected end of this year, and logs probably by the next year. Okay. So with all this, thank you very much for listening. It has been my absolute pleasure, and good luck in your OpenTelemetry and telemetry journey. Thank you.